Hello, welcome back. This is my second tutorial. Last time we talked about function, domain, and range. If you remember, the domain is a set, and it is a set of numbers which is all possible number that x can be, and E is called the range, and which is all the possible numbers that fx can be. Okay, so today we're gonna just look on several examples, exercises. We got different functions. We got quadratic, we got fraction, we got absolute value sign, we got logarithmic, and we got exponential. So based on different kind of function, the domain and the range, these are possible numbers, will change based on different situations. I'll demonstrate that. Let's do it. So today we have this. Let's start with the first one, function with the square root one. Okay, we know the square root. Under the square root, the property of the square root, under the square root, this part, x plus 2, this whole thing, anything under the square root should be greater and equal to 0. Right, greater than equal to 0. And those are the restriction for the domain. Okay, because it's in the x in here. So if I solve this, I move the 2 over. That means it gave me this. So you end up with x greater than equal to -2. That means it's not just one number such that if you remember the number line, I can draw a number line right here. If I have a 0 right here, if I have a 1 right here, I have a 2 right here, I got 0, -1 right here, and -1 right there. So the x is greater than -2. That means from here, since it's also equals to -2, that means I got a big solid dot right there, and I go all the way to the right side, since because it's greater than. Right. So domain is all the numbers from -2 to infinity. Another way of writing it is this. Infinity is imaginary. I mean, it's not a real number. We cannot count how much is an imaginary number, right? How much is this infinity? So we got a parenthesis here. So domain will be bracket is all the numbers are greater than equal to -2. Okay, and for the range, we're looking for this fx. Since this fx is equal to the result of the square root, that means that the result of square root is always greater than equal to 0, right? That means this is always greater than equal to 0. Okay, so since this is greater than equal to 0, that gives me, if I draw a number line, because this is for x, okay, and this is for y. If I have a 0 right here greater than equal to 0, it's like that. So this is a domain and a range. We're not looking for one number. Sometimes it only gives you one number. It's really rare. Depends on what kind of function you have. But this typically for the square root function, we have this kind of situation. So the domain is for this problem is greater than equal to -2, and range as a result of square root, it should be greater than equal to 0. Okay, let me get a second one, fraction. The name of the function is not matter. I can use all kinds of letters here. I can put agents here, I can put p's here, I can put g's here. You just give a name called the function g, function f, function h, function p, and function q. You just give a name. So this name will have the function g of x is x squared minus x. Okay, it's x squared minus x. So we know the property of the fraction, something has to do with the denominator. And we know this denominator, anything there, or anything in the denominator that should not equal to 0. So x squared minus x should not equal to 0. Okay, if I can factor this, I take the x out, I get this. So this is a multiplication in between, that means I can separate them. That means I got two parts that both, they each cannot equal to 0. X cannot equal to 0, and x minus 1 cannot equal to 0. So they, right? Okay. If I draw a number line, I got a 0 here. How much is this? X minus 1 doesn't equal to 0. If I move the 1 over, that means x is not equal to 1. Right? 1. If you learn, this means 0 is an open circle, and x is open circle. 1 is an open circle. So they're both open circles. And they kind of including everything else. It just x is not equal to 0 and x is not equal to 1. So it's like this. This is the infinity negative side. This is the infinity positive side. And you see that. So two open circles. We don't want those 2 points, but we're left with the rest of it. Okay. If I write something like this, okay, how should I write it? I start from negative side, infinity, and then I don't want 0. I put a 0 and put a parenthesis here. That means I don't want 0. If I want the bracket, that means I including the negative 2. Since I don't want 0, I put a parenthesis. And I start parenthesis again from 0 to 1. I take this part and I put another part, 1 to the infinity. So I got 3 parts. You see that? Okay, this is how you read it. So for the answer g of x, is the result of fraction. If you think about it, the result of fraction can be anything. It can be positive, fraction can be negative, a fraction can be a really big, like 800 over 1. It can be 1 over 800. There's no too much restriction on the result of the fraction. Okay, that means this has no restriction. Okay, there's no restriction on this. That means this g of x is all real numbers. This symbol is all real number, representing all real number. All real number means negative to positive infinity. Means this. They are equivalent. Yeah. So if there's no restriction, no points being taken out, that means we got a whole set from negative infinity to positive, adding numbers in there, all the numbers in there. But all real numbers in there. You don't want imaginary or I, if you learn later on. Okay, now we look for this example C. C, we got h of x, and that's bounded in the opposite value sign. Hold on. Alright, so we got this opposite value function. Okay, So we're dealing with is plus 2 inside the opposite water sign. This is plus 2. But what's the value of the x plus 2? You always can ask your question, because sometimes we there's no restriction, right? Is there anything that the x cannot be? Cannot be. So there's, or is there restrictions inside of the opposite water sign? But if you look at it, you can put positive numbers in, you can put negative numbers in, you can put decimals in there, you can put zeros in there, you can put really large numbers there. You can put mostly anything. So that means this part has no restriction. That means this part all real number. Okay. If you look at the set, if you have x plus 2, it's all real number. Okay. If you think this, like x plus 2 is being bounded by negative infinity and positive infinity, kind of like this way. But if you minus 2 on both sides, okay, negative infinity minus 2, if you go for a limit, it doesn't really minus anything, because this infinity is so big. That means still it remains an infinity. And this part, since the infinity is so big as well, it still remains as infinity. So I'll say my x still remains with this bound, negative infinity to positive infinity. That means what? That means I got this set. That means I got this set. Right? You couldn't see it, but I give you right now. So it's between negative infinity to positive infinity. Okay. So that means, how about h of x? H of x is the result of the absolute value. Okay. If you're familiar with the absolute value, I'm just making this is not the answer for those things. But if you've got positive 5, right? The absolute value sign definition of the point 5 is the distance before this to the origin. This is what it means. If I have absolute values 5, the distance is 5. Okay. If I got negative 5, the absolute value sign, the distance is absolute value of negative 5. They both equal. The distance to the left and distance to the right, they are the same. It's like 5 to each side. That means this, the result of absolute value sign, the result of absolute value sign is always greater than or equal to 0. If you are at the origin, you're lucky. You don't need to move. The distance is 0, right? Since absolute value sign, the result of absolute value sign is always greater than or equal to 0, that means this is greater than or equal to 0. Alright? So I can write this from 0 to positive infinity. Okay? Okay, for the second part, I can show you the rest 2 problems. Hold on.